I think it makes sense to further continue going down with the fundamentals. And once we understood the really basics and fundamentals, we will go into how to properly use it and how to use some of the plugins. In order to do this, I think it makes sense for this, like we have booked 1 hour, but nevertheless, in 1 hour, we should be able to do something pretty cool, which should be something like, let's open a new project, which should be something like re-implementing the Kotlin Gradle plugin, just the basics, so you can compile a project. Projects can maybe resolve dependencies or can depend on each other, just the very basics. So for this one here, let me create a new project somewhere, a home directory, test projects, new folder. Yeah, so let's start with an absolute empty project, and we are trying to re-implement the basics of Kotlin Gradle, of the Kotlin Gradle plugin, and with that we will see how you would even implement a Gradle plugin from scratch, what a Gradle plugin actually does, and how all of it works under the hood. So I have this really empty project. I will now just create the necessary files to make it a Gradle project. So let's start with our build Gradle KTS file, link the Gradle project, or let's do it like this, link Gradle project. And now let's also add our settings, Gradle KTS. I will just create 2 modules and set them up as like Kotlin modules where they contain 2 source files, and then we build something that is able to compile those 2 source files and even have those 2 projects depend on each other. So I think we can go and have one module called foo, one module called bar. Now let's create those from scratch, foo. And as always, if there are any questions, just interrupt me and we will tackle those questions. Okay, now let's create some pseudo like SSC main. Or let's just do SSC. Let's have like SSC, and then we have a bar.kt. Yes, create a file, and also we want to have like a file that is called new file, SSC, and then here we have foo.kt. We have a function bar, returning bar, and we have function foo print line calling into bar. That is like a very simple Kotlin project. You have one project as a library that provides a function. The other project will use this function to print it out to the console. Very, very simple. Now let's build the Kotlin Gradle plugin that would actually compile this. And maybe if we would get to that point, we can even try to build it in a way that it is able to execute this code. So in order to do this, of course, those 2 modules should be Gradle modules. So build Gradle KTS for this one. We add a file build Gradle KTS. And since we want to build our own version of the Kotlin Gradle plugin from scratch, there's not a lot of things we can do here because we probably won't want to apply the regular Kotlin plugin. We want to build our own Kotlin Gradle plugin and see how Gradle plugins work. So for this, I think we can start talking about the buildSrc. buildSrc in Gradle is a special module. It is similar to regular modules, as in like you can have a build.gradle.kts file in it, and you can build code. The difference to regular modules is that this code is available at build time. So if I am writing something like previously tackled or previously mentioned, like tasks, or I'm setting up configurations in my Gradle project, in my build Gradle KTS, for example, foo or bar, I could use code that I've written in buildSrc. But we also can use buildSrc to build our own Gradle plugins. And that's what we're going to do. So in order to build a Gradle plugin, yeah, Eugene?
So you mentioned that it's the code available during building, and what about configuration stage, or it's included?
That's what I meant. I can show one very simple example before we even start to build up projects. So let's just set up buildSrc. So we compile some code that will be available at build time, and then I show what this means. So let's do this by just setting up a very simple project that is allowed to use Maven Central as repositories. And let's just use very plainly a Kotlin JVM here as like, let's go with the version 1.9. I am more familiar with 1.9 right now as with Kotlin 2. And since I have not prepared anything for this workshop, it's better to stick with things I know about. Okay, buildSrc, we have like a really basic Kotlin project. So let's select something here. Let's create our stupid package. I always tell my Kotlin because we want to have our Kotlin plugin. So let's give it a nice package. Tree appearance, I would like to compact the packages. And now let's just have like a simple stupid class called class stupid. I can sync here. And what you should see now, it is doing syncing, it's compiling this buildSrc. And now let's just write something really easy in this build script. Let's say we want to have a task, create example. So it's an example task. Inside here, we can should now be able to access stupid. So if I stupid suggested, yeah, you see the class is available and I could just access it in here. So this is what buildSrc means. You can write code and it will become available for your build scripts. So you can write, you can use it in your tasks. You can use it to configure your tasks. It's just code that is available here and shared across all the projects. So you see why it would be really convenient to use a buildSrc. Yes?
So it means that buildSrc is built and compiled in the first place always.
Yes, this is what you see here. If I just let's do Gradle again. It's just a shortcut to /Gradle. It's just an alias. The first thing it does, it is compiling buildSrc, then it compiles the build scripts with the output from buildSrc. So yeah, that's exactly right.
And about like in the previous talk, you mentioned that Gradle and modules support caching and they verify whether modules are changed, and the same rules apply to buildSrc.
Yes, if you change something in buildSrc, then it means it could invalidate some of your tasks because they're dependent on buildSrc. So they need to be rerun as they become dirty. It's the same as if you would change the code inside your build Gradle KTS file. So if you change the code in the build script, Gradle will detect the change in the build script and say like, okay, the task is not up to date because the build script changed, so we need to rerun it. Right?
Okay.
That makes sense.
The last question about the module. So if this is a regular module, it can have dependencies. Like I don't know, if I want extra.
We will come to how we do dependencies because when we are going into re-implementing the Kotlin Gradle plugin, we will need the dependency to Kotlin compiler, and then I showcase that you can just have regular dependencies and just write regular code, and it will just be available on your build time. So when we re-implement the Kotlin Gradle plugin, we will declare dependency to the Kotlin compiler and then use it when we create the task.
Okay, clear.
Okay. So let me show how we can potentially write a Gradle plugin. So there are some really nice wrappers or plugins to write Gradle plugins. So the first thing that we can do is we apply the Java Gradle plugin. It sets up some nice things for us. It allows us to configure Gradle plugins within this build script. And I think what is also really nice is to have the Kotlin DSL. Here it allows you to use some nice Kotlin shortcuts to write code for Gradle. So those two plugins are really nice, and we can just sync and see what they do for us. And then we will just create our own Kotlin plugin. So we can delete stupid here, and we can replace it by something that we call a Kotlin plugin. So what is a Gradle plugin? It is a very, very simple thing. It is an entity that just implements plugins from org.gradle.api on the level of a project. And all it does is it has to implement an apply function, and it gets this target. Remember that when I am writing code inside this build Gradle KTS, let's take a module bar here, for example. So I'm jumping into build Gradle KTS. What is this here is basically the project. So I hope for autocomplete now, but this is the entity here from this is like a Kotlin build script, and it will inevitably implement or extend project. So everything you can do inside here in your build script, you will be now able to do here in the project. So you now get the target project, and you can configure this project. So if you would want to implement or re-implement the Kotlin Gradle plugin, first thing we want to obviously have is a compile task, right? We want to be able to compile our Kotlin code, so we should have a task, in my opinion, that is something like compile Kotlin. Very simple. It takes the source code and it transforms it to class files. So we recently learned how to write tasks. So let's create this task and set it up, and then set it up so that it is even exposed to other projects, as we have learned in the previous session with configurations. So what we want to do is we want to have an open class. Remember, open because Gradle does magic to it. So it will at runtime extend or implement this task and inject some properties into it. So we have like the Kotlin compile task. And remember that, or for this session, I will not mention JVM because we will just implement the JVM compilation. Obviously, multi-platform would be way too complicated. So let's focus on JVM. So there will only be one task, the Kotlin compile task. And here it implements default task. And it should be, for now, quite opinionated. For example, we can tell this plugin that it should always look for source files that are located under the root, under projects folder, SOC, and then it should collect all the Kotlin files. So if you want to collect all the source files that we need to compile, we can again do this as like internal property. Let's call it Kotlin sources. And what we can do here is we can use some APIs from Gradle that conveniently allow us to traverse a directory and collect all the files in there that match a certain pattern. So in this case, what we can do is we can access the project. We can ask for the project directory. We can resolve the SSC folder. And then we can create a file tree. So we can do something like project.file tree, and then project directory resolve, and then the SSC. With what this file tree function does for us is like it returns us a collection of files, like it just traverses all the files inside this directory. Of course, in this situation, we only care about all the files that are actually matching a certain pattern, which is they should end with KTS. So we can do something like we only care about something that that includes KT. So we have this Kotlin sources, and for now we can mark this as an input. We can mark it as input files, and we can see already if this would work for us by now going to this target and applying the task. So first, before we even apply the task, let's see if our plugin is somewhat alive. So we do something like print line and say like hello from our plugin. So the quick question is, how can we get from us declaring just somewhere a plugin, how can we get to this plugin being applied inside a plugins block in our build Gradle KTS that we want to use inside our real projects? You can see it suggests me to use here ID Kotlin, but how would we obtain such a string and how will this resolve to our actual class here, this Kotlin plugin. Conveniently, this is what this Java Gradle plugin is helping us with. So we can configure our Gradle plugin by using that DSL. So we can do something like plugins, and we create a new plugin. We call it, now let's call it My Kotlin. And in here, we provide an ID. This ID is exactly what you would see if I am now using here as an example com.android.library. This is the ID of the plugin. And when we go into the buildSrc, we need to select something that is representing our plugin. So for this, I would go with something like io.selmari.kotlin, which is the ID of my plugin. So if I would want to apply it, I could apply it by calling here io.selmari.kotlin, and fair enough, it should apply my plugin. Now, the only thing missing is that we need to tell it what the class it needs to actually apply. So here's an implementation class, and it almost correctly predicted what I want to do. The implementation class is io.selmari.kotlin, then Kotlin plugin. Yeah.
The confusing part I see sometimes is that some plugins has version and others not, and you just don't define it. So by default, there is no need to define any version.
There is. I will talk about this in upcoming sessions, I guess. But as a small spoiler, the reason why we will not be required to specify any version in our current example project is because we have the plugin available in our class path, meaning buildSrc will be compiled, and then we compile our build scripts, and then it will look up for whether or not it can find this ID somewhere in our own class path. And it will do this by looking into, we can quickly build this, and we will be able to see how it actually, oh, 1 second, what happens? Yeah, stupid is not available anymore. That makes a lot of sense. So let's go again. Let's look into plugin descriptors. When you package or you build a Gradle plugin, it will provide a resource file that looks like this. Like it has the ID of the plugin, doc properties, and then it points to the implementation class. And what Gradle will do if it looks for a plugin, so it will resolve this. Let's go here. We have a plugin, and we want to call like something com Android library. It will look for if there is something at runtime available that tells us that it can provide the implementation class for com Android library. And since in this example, we will have our plugin coming from buildSrc available already, we don't need to provide any version. But if we would provide a version, it tries to find the dependency as if you would go and declare dependency to any other library. You will be required to provide the Maven coordinates. There is something not magical, but there's a pattern on how Gradle will then try to find the coordinates for how it can download this Gradle plugin based upon the ID, and then it downloads it, puts it at the runtime or the compile class path, and they will be able then to find the plugin. So long story short, for now, let's not focus on versions. You will, in the end, be required to provide versions for most of the plugins at some point in your build. And in this case, you don't, because we already have it available. It doesn't need to download it. It compiles it from buildSrc. So clear?
Yeah, makes sense.
Okay, so let's continue. Let's try to see if we get the heartbeat from our own Kotlin plugin. So let's go ID, and I think it was my name, and then Kotlin. And now let's see if the command line gives us back the heartbeat. Yeah, it says like when it tried to configure the project bar, at some point it called hello from our plugin. And basically, this is what you do if you load plugins. It will first, Gradle does a lot of things that are complicated, but in this particular case, we can simplify it as if you declare a plugin at some point before your code is running here. So we can do something like print line hello from our build script. And before it even runs our own build script, it will call the .apply function from all the plugins. So if we now, again, just configure the build, hello from our plugin, hello from our build script. That makes kind of sense, right? So the plugin can first set up a lot of entities, and then you are allowed to configure the entities that were set up by the plugin. So if you see in the real Kotlin Gradle plugin, you will see that you are allowed to configure Kotlin. And this extension is provided then by this plugin, by the plugin being like the plugin's API apply function will be called. This apply function will register some extensions, and therefore you are allowed to configure those extensions in your build script. Let's go back to our example plugin and implement that we actually apply a task. So buildSrc, we go here, Kotlin plugin. Now instead of just saying hello, what we can do is we can say like target tasks, as we learned, register, compile Kotlin. It again almost correctly predicted what we wanted to do. So let's register the Kotlin compile task. There's no need for us to configure it right now. So let's try this out. Let's see if we can see the task now in our build script. So one thing that you will learn about Gradle is that if there's there is actually magic going on with this plugins block, because it's the script before it even runs the code here or even compiles the code here, it did some magic with this plugins block, because you will now see that if I sync here again, so the ID gets all the goodies, and I'm asking for tasks, I see magically this compile Kotlin. And what this is called is an accessor. And you, Eugene, I know that you already struggled with accessors once in one of the Objective-C export builds that we have. How this works is that when doing the apply of a plugin, the plugin registers an entity that is static, like for example inside tasks, something statically call compile Kotlin. Then Gradle will generate accessors. This is an accessor, so you can just use this. It even comes from, I think we can look into this by command clicking. And when we look into where this is coming from, it's coming from accessors, blah, 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 KT. And this is something you will see a lot of time. This is how Gradle plugins are allowed to extend your build script. So you can, for example, open this Kotlin block. You can use this compile Kotlin and configure this task in here. And it all feels like those entities and DSL elements are always there. And the reason for it is because they are there. They will be auto-generated code from Gradle for you. So maybe this explains how you're able to access some entities from Gradle plugins in such a nice way. So in this case, if I want to do the compile Kotlin, for me, it would be really interesting if we could just see if it picks up all the necessary Kotlin files already, if it is able to actually see this bar KT. So I think for now we made this, we made the property internal. So let's just make it public for now so that we can access this. Let's sync again. Kotlin sources, and let's just do something we learned that we can run additional code on tasks by wrapping them with do first or do last, and so we can just print all the Kotlin sources. So let's do print line Kotlin sources. Let's join to string and print them in this way. So if I'm now calling compile Kotlin on the command line, yes, it is able to pick up that there is a bar, and we can now try to see if it actually also picks up something like from my.package, and now let's create a new file, test.kt. So I'm now trying to compile. Yeah, it finds now the test KT, it finds the bar KT. So what it means is our task here is able to find all the Kotlin sources in the SRC folder correctly. Very nice. So what we want to do is we want to actually call the Kotlin compiler for this task to compile the sources into class files and then maybe even expose them to other projects or package them to a jar file, whatever. How can this be done? So for this to work, obviously we need to get the dependency to the Kotlin compiler, and I need to look up the dependency. So I think somewhere I have a different project where I can just look what dependency coordinates we need. Okay, so we mentioned that we can just use dependencies. So let's do this in our buildSrc where we write this plugin. I'm copying the dependency notation here. Let's just use the Kotlin compiler embeddable. Again, let's use 1923 because I am pretty familiar with this version of the compiler. So let's sync. And let's see how we can compile the sources. Okay, now our task action sync. Yeah. Compile. What this will do now is it needs some kind of output directory. So let's provide this output here is project dot layout learned build directory here. Let's call it classes. So we put all of those things into this classes directory, and we mark this as output directory. So Gradle will check the input file. So if we're adding a new Kotlin source file, or if we are changing the existing Kotlin sources, it will mark the task as not being up to date, and it knows that it has to rerun the compile task. Also, if we would delete something or change something from the output directory, it also marks the task as dirty and knows that it has to recompile the Kotlin code. So setting up the Kotlin compiler is actually not that hard when we do the simple cases. So let's just go to the output directory and get this output directory as file. Now if we actually are running this task, let's make sure that the output directory is completely removed because we don't want anything dirty. And then make sure that the output directory file create directories. Yeah, that the output directory file exists. So we just call this make tiers. Now, in order to call the Kotlin compiler, we need the compiler arguments, and that's not too hard to do. So Kotlin K2 JVM compiler arguments. Now we want to have like arguments no standard lib. To be set to true, we will provide them manually. We'll set this to them. We will have to set a module name. So in this case, we will use the project's module name. In this case, we can also check it as an input. Well, module name equals project.name in this case. Module name. The dependencies we don't yet need, but we can set the destination file. Destination as file equals the output directory file. Okay, so we have the destination provided. We provide the sources to the Kotlin compilers by specifying them as free arguments. So arg.free args equals, and then we go to the Kotlin sources, map, absolute path, and I think we can already try it out if this will actually compile. Let's see if we will need to provide the standard library and if we need to resolve this. But for now, let's try to compile this bar project that we have. So We can remove this configuration, save it, and we go bar compile. Says it's it's successful, but it doesn't have any classes. So that is.
And they need to invoke compiler.
You're right. You're right. I think that I just set up the arguments, right? I did not execute anything. Yeah, that makes a lot of sense. So I forgot about the most important part. So what we need to do is call the K2JVM compiler, and then we call exec. We want to specify how we want to render the messages that are provided by the compiler message. Gradle style, and then we want to use the args to argument string, and then to typed array. So basically what this does, like maybe we can the names to call arguments. We need to provide an error stream. We need to provide a message renderer. And I think, yeah, the arguments are provided here as this typed array. And now let's try again if we are able to compile the Kotlin code. It's successful. And now let's see. Oh, that's kind of nice, right? We have now bar KT, a class. We have the Kotlin module here. Quite nice. We are now able to compile this to an actual class. So how would we connect bar and foo so that foo also compiles? Let's go to foo, apply as well our plugin. So the ID was sell my Kotlin. And if we would like to compile this project, we will see a compilation error because it depends on the function bar that it lives in this other project. So we need to declare a dependency. So in this case, foo compile Kotlin. Yeah, we will see two issues. We have an unresolved reference print line because we have no standard library. We need to fix this. And we have an unresolved reference bar. Of course, we did not even try to create a dependency. So just to showcase how Gradle works and give and to provide some kind of intuition, we have this task here, and I would like to show you how this up-to-date checking works. So let's quickly go and compile Kotlin from bar, and you should see if I do -I. It seems like it should say something like it is up to date because, yeah, nothing changed. The inputs are still the same. The output is the same. So in our cases, we can, for example, now delete the classes directory and see how Gradle behaves if I'm now compiling this again. It says it's not up to date because output property, output file has been removed, has been removed, has been removed. Quite convenient, right? What happens if I change the code from something like from bar to hello? Let's see if it picks this change up. It says input property Kotlin source files bar has changed. So if I compile once again, it says up to date. If I provide some gibberish and I compile again, it says now it's not up to date because the input source file has changed. So this is quite convenient. You now get an intuition on how this up-to-date checks works. And when things are simple, I would say it's quite nice and quite beautiful to do this. You basically annotate the properties of a compile task or a compile task of any kind of task by telling Gradle what kind of input it is. There are more complicated ways of providing input files. Like if you look into the real Kotlin Gradle plugin, you will see that we use. We also tell Gradle about how it should treat paths, whether or not they should be treated as absolute or relative. And we can do a lot of different nuanced strategies on how to tell Gradle if certain things are considered up to date or not. But for our very simple use case, this is pretty good enough. So we will be able to detect if something from the input changed. So we wanted to make sure that we can declare dependency from food to bar. And how this is done is similar to what we've shown in the previous session when it comes to configurations. And remember this outgoing configurations thingy. Let's do this in our plugin. Let's create such a configuration that is allowed to share the output of your compile task with any project that depends on this project. So what we do is we go to configurations, we create something, and we call it, let's call it API elements. That's just me reusing a term from the real Gradle world. We can choose whatever we like here. Again, we say like it can be resolved as false, and is can be consumed is true. So it signals to Gradle that this is something that is outgoing, like this should be used to ship something, but not to receive something. So here, these API elements, we can also declare an artifact. So let's do this by saying here, compile Kotlin task, and now we do outgoing artifact, and we can try to see if Gradle picks up the output directory here as an output directory. And also we want to have some kind of attributes so that we tell Gradle what kind of semantics this has. Again, we talked about this in the previous session, but as a short, we are going to tell Gradle that this outgoing configuration is to be used as compile something with Java. So we are like an API, like we are, it can be used to compile Java code, not necessarily to run Java code, but to compile Java code. So what we are doing here is we call it like we provide the attributes like a usage attribute, and we say project objects named usage Java API. I think it's target in here. Okay, so we tell it it's used to be as it should be used as Java API, and we can also specify category, and then category attribute, and then we say as a category, we want to say it's a library. Here we also need to provide, we can just use the extension function that is nicer. Okay, so we tell it it's a Java API library. Fair enough. And when we want to use this, we can also set up the incoming configuration for our plugin and consume it. So target configurations, create. Now let's create implementation as it is what we actually want. And this is how the actual Kotlin Gradle plugin also similarly does set up its implementation configuration. In this case, it can be resolved, it cannot be consumed, basically telling Gradle the other way around, like this is something to get artifacts from, not to ship artifacts. And we will basically just copy the same attributes. So if Gradle will look for some dependencies, it tries to find the artifacts or this outgoing configuration that matches this attributes. Fair enough. Now we have implementation, we have API elements. This is to share our compilation with projects that depend on us. And this configuration here is intended to resolve and get artifacts from dependencies. Now, how would we wire this to our compile task? What we can do here is we can configure this compile task in a way that we allow to specify dependencies. So that's what we are going to do. We say something like, let's call it libraries. Libraries, or not dependencies, it's nicer. Dependencies, project, properties. Now let's see if we have a configurable where we can create a file collection, a configurable file collection. Yeah, we can just say like files. So it's a configurable file collection. We mark it as input as well. So let's maybe also move it nearby the other inputs. And in this case, I am using class path as an input. You can read this. It is very similar to input files, but it is a little bit more clever. It knows about jar files, and it knows like, oh, if inside this jar file there was just something changed, it doesn't affect Java compilations, then it's still up to date. So, for example, if previously you shipped class A as the first entry in the zip file, and then class B is the second entry in the zip file, and then the next iteration they just swap position in the zip file. Who cares? Like, it's still, both files are there. They are still the same files inside this jar or zip file. So let's not mark the task as dirty. This is what this class path is doing.
Is changing the comment considered the same in this particular case, right? If you
Yeah, exactly. Yeah, exactly. So it's a little bit more clever on detecting whether or not something is up to date or not. Okay, so we have this implementation here. Implementation, let's call it configuration. And now let's just wire it up so that our compile Kotlin task, we configure it. This is the way that we can do stuff lazy. We do not get the compile task here. We get a task provider. So if and only if Gradle determines that it wants to actually materialize this task because it needs to be executed, only then it will run all of this configuration blocks and does the heavy lifting. Sometimes it's not that heavy as people think it is, but most of the time it's just nice to be defensive about it and wrap your configuration code inside this configure. So it only executes your code if it really needs this task. And inside this configure, we will do something like dependencies. And let's just add implementation configuration here as well. So we just say like, okay, add the dependencies. Like, this from is basically doing this, adds a set of source paths to the collection. The given paths are evaluated as blah, blah, blah. Basically, all the files that are coming in here should be available inside our dependencies. Okay, let's look at how we can also add the dependencies into our arguments. So this is done by class path as list, and we do something like dependencies, map. I think we can basically, I think we should make sure that it's an absolute file. So we do file dot absolute file. Yeah, now we are able to tell the Kotlin compiler even that we want to have some kind of dependencies. Really nice. Let's try this out and see if it breaks, because I actually don't know if it will break. Let's compile bar, and let's see if something is broken here already. Okay. Now let's see if I am thinking, if we can get that you can, like, this implementation suddenly. And that will also then explain where this implementation, compile only, runtime only, where all of this stuff is coming from. And the answer is coming from plugins. So in here, we do not have anything like API. We have API elements. It's what we provided. We do not have compile only. But what we have now is implementation. Implementation, because we have defined it in our Kotlin Gradle plugin here, and defined that there exists a configuration called implementation, and therefore Gradle is nice enough to provide us this utility function. Now, what we want to have is let's add the Kotlin standard lib. That probably is just nice to have. So let's add Kotlin standard lib and see if it is there. We can see if it's there by, again, hooking into our compile task and printing stuff. So task, compile Kotlin. Actually, I told that we should be defensive and we should use configure where possible. So let's use configure instead of the eager APIs. Do first, let's run like our debug or like investigation command first. Print line, dependencies, join to string. So let's see if this works by us now resolving the Kotlin standard value. very great task, blah, blah, blah. Kotlin could not resolve external dependency or blah, 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 Kotlin standard lib because no no repositories are defined. Fair enough. We don't have a repository defined, so how should we download a dependency with no repository? Let's use Maven Central. Oh, and let's see what's going on now. Could not resolve all, could not find. Okay, I think what we need to do is provide a version. Like there are some goodies inside the Kotlin standard library that allow you to not specify the version here. Oh, quite nice. Now it doesn't complain about not being able to resolve. And if we look into our files that we have, we see we not only have the Kotlin standard library, but we also resolve the org.JetBrains annotations as it's a transitive dependency to Kotlin standard lib. How exciting. We can now use the Kotlin standard library. That being said, as we have learned about configuration in the previous session, we should now, out of the box, be able to also use a project dependency from foo to bar, because foo will request the outgoing configuration from bar, which should then trigger the compile task and therefore provide me the classes. What I'm not sure about is if we will be able to ship, like if we are able to compile with the response of just the directory containing the classes, or if we need to provide all the classes. If I remember correctly, just pointing to a directory that contains the classes should be enough. Let's try it out and see. Inside foo, we do something similar. We go implementation, and we should also provide the standard library as we want to have this print line function being available. So standard library 1923. And now also let's use project, and we want to resolve the project bar. Let's try this out by compiling foo compile Kotlin as a dry run first and see if it actually figured out that in order to compile foo, it needs to compile bar. How exciting. Let's actually execute this code. Because no repository is defined. Now I'm fed up with defining repositories in every project, and it's basically not a nice pattern anyways to have different repositories in your sub-projects. Most of the time, you should just have one set of repositories and use them consistently, at least in my opinion. So let's just define the repositories in our settings, Gradle KTS, and make sure that they are just the repositories and we do not have to redefine it everywhere. So to do this, there's like dependency resolution management. And inside there, we can declare the repositories that we want to use across the entire build. Now let's see if this worked for us. I'm sorry, I messed up with this font size. Yes, it worked for us. Build successful. So it seems to me that we were able to compile this project. So if we look into foo here, is there a way to use the, it's already compiled code. You can see that we are able to now compile those two projects. And what happens now if I am changing something here? And maybe you can ask yourself what you expect from us now. But in this case, it seemed that there were 4 tasks up to date and 3 executed. Maybe it would have been nicer to provide the -I flag. So let's add more gibberish here and re-execute the compile task. And you can see the input properties, dependencies of bar KT class has changed. Therefore, we had to recompile foo compile Kotlin. This is one of the ways where the Kotlin Gradle plugin can be much, much more clever than what we have done in our simple, like, how long are we in? Maybe 40 minutes. So, of course, you would now expect that if there's just a string change here, we should not entirely recompile this dependent project foo, because it's not a change that will affect the resolve of bar. So nothing really changed from like the headers from bar. So we should not have recompiled foo. But as like a first prototype of building a Kotlin Gradle plugin, I think this is quite exciting. If it did not change anything, it will recognize that everything is up to date. If I delete the output from bar and I want to recompile foo, it will tell me, oh, we had to recompile bar because we deleted the classes. But interestingly enough, it realized that, oh, despite bar being recompiled, foo is still up to date because the compilation of bar just produced the same class files. Therefore, it's still the same operation. We did this previously. The files are still on disk, so there's nothing for us to do. So we could even try out if it works for more dependencies, so we can see if we can use something like org, JetBrains, Kotlin Xcode core, but maybe a new version. And we can see if we actually are allowed to call Kotlin. How is the run blocking signature? I think it's maybe if somebody would be able to look it up, that would be really nice. But maybe I am able to do so as well. Run blocking comes from the package Kotlin Xcode. That was predictable. And now let's say print line hello from 14th. Let's compile and see if it now is able to compile even with the dependency as coroutines. And yes, it downloaded coroutines called JVM jar, and it compiles it. And to prove that it actually compiles it, let's produce a compilation error by me providing gibberish in the code. Let's compile again. Oh, yeah, that was a nice proof. So what is going on here? We have bar, compile Kotlin, bar has changed. Bar KT should have been compiled.
I think it's all fine. It says unresolved reference.
Oh, it did. Ah, yeah, here. Ah, yeah. Oh, it said it says build successful, but it exits with an error. So I think we should somehow crash instead and tell Gradle that we did something bad. Interesting. Yeah, I thought that. Let's go to our buildSrc source Kotlin plugin. Here's where we compile exec. Maybe this is returning us something that we should. Exit code. Yeah, so we should probably check the exit code. So exit code equals, and now if exit code is there exit code like exit code dot okay. Oh, let's see if exit code. Yeah, let's do it like this. Then we should throw. Let's just not throw an exception by defining exception type, but let's just use error. I did not compile exit code. Okay, now let's. Yep, did not compile, compilation error. And here's the error, unresolved reference. And if I change this to run blocking, we should now be able to compile it again. Yep, it compiles. I'm not sure how much more time you have, but it would also be interesting to see how we could create a run task that actually launches this code. But I think it would take 10 more minutes to show how we would launch or create a run task that launches the code and runs it. But if you're out of time, then that's also fine.
I'm fine. I have time.
Okay, then let's continue. Nebojsa, I hope you're also fine with this. So,
Yep.
Let's create a run task and just similar to the Kotlin compile task here, we do an open class Kotlin run task. It again implements the default task. Now, what this needs is class path, so the classes that it runs. So and we do a sneaky thing on how to run it. We do not use the proper Java X. Let's riff on that. Like, I'm not sure how we do it. I think we do it sneakily by just creating a class loader and running stuff. But let's see. Okay, class path, we need the classes that we want to run. So class path, project files. Then we want to have a main method. Main class. Properties. Project providers. String, how is it called? Objects, string provider. Right. I'm struggling here. How is the string provider? There's a nice factory function for providing strings. Providers or properties. String, no. And Gradle property. It's just objects. Come on. I showed this in the last property. I think there is no string property. It's just like it's just a regular class. That makes sense. Okay, sorry for that hiccup. That's the input. So we need a class path, we need a main class. And if we want to do it the sneaky way, we could also provide a function that we want to execute. So it's not limited to calling main, but maybe we can just start by having automatically call into the class main function. So the function actually needs to be called main. So again, we provide a task action. We call it run in this case, and we resolve the class path. So we go and resolve it by calling .files, which will return us a flat list of actual files. So you can see here, classes is a set of files. And now let's use project. Java exec is a nice way of doing this. We can set the class path. Oh, we can actually even set the class path to class path, and we can set the main class to main class. Main class dot set. That was simple. So what we want to do here is in our plugin, we want to wire automatically in that the run task sees all the dependencies and it sees the output of our own compilation. So let's configure our compile task, run task. First, we want to register it. Run Kotlin task, target tasks, register Kotlin run task. Let's call it run Kotlin. Run Kotlin task, configure that task. Now we want to specify that its class path is, I think we can even do something like plus equals, and then compile Kotlin compile task out map output directory. We want to provide it as files. So let's see how we can wire this up. Okay, we want to have the files that come from this output directory. I'm not sure if we need here to actually walk through and collect all the .class files. Now let's see class path here and also add the dependencies. So here, implementation configuration, it should also be added as the class path. And let's let the user set the main function to run. So in this case, let's go to foo and also provide a function main. And this function calls into foo. Very simple main function. Let's try to configure it and tell it that the main class to be executed should be foo. So what we do is tasks, run Kotlin, configure, We set the main class to, and it's just foo KT. Remember that there's foo by default gets a class called foo KT. You can see it here, foo KT.class. Let's try to run this code and see if it actually prints something on console. Foo run Kotlin. Stack Overflow error, no message provided. So let's see where we messed up. Let's use -s to provide. Okay, abstract property, calculate presence. Yeah, I think we can look into where we did this mess up. I think it's here somewhere where we set this main class. Of course, if we say this.main class set main class, we are basically short-circuiting it. We want to provide the main class from the task. So here from the task, this main class. So let's try it again and run it with -i instead of the -s for stack traces and see what happens. So could not find or load class foo KT. And this is what I kind of expected. So what we actually should probably do is, again, go and collect all the class files instead of just providing a directory as the class path. So in this case, in order to make it run, we do a similar trick. We go using the file to function, and we match everything that is a .class file. Let's see if this works for us.
Do we need map in this case?
Hmm?
Do we need map in this particular case? Because I guess that we're only, I mean, when we call compile Kotlin task.map, we are mapping every Kotlin compile task and every output, right?
Yeah, this map is just to ensure that everything here is still lazy. We could simplify the code by basically getting the task, which would require to materialize it. So in this case, only if the run Kotlin task is configured, it will actually call into this code and it will materialize the compile Kotlin task. So if we need this property output directory from compile Kotlin task, we need to wrap it. I think for this here, class not found, exception still foo KT, I think we should just debug it by looking into what is available in the class path. So maybe we did again the same stupid mistake. This at Kotlin run task, of course, we want to reference the class path that we have here. So let's see again. Run the Kotlin code. Compiling. Sorry. Class not found, foo KT still. So let's see if we can provide a do first here to debug the task. And we say like print line, class path, join to string, and let's go doing this. So we actually provide -cp foo KT class. I think the misconception might be that it has multiple ways of specifying. CP, it provides the foo KT class. Could not find main.
Do we need to specify .kt in the main where we configure the main class?
Yeah, it should definitely be added here. So let's not use this Java exec. I'm not sure what fails. Maybe let's go a little simpler.
I mean, does the Kotlin compile task allows defining main class without KT extension?
The Kotlin compile task?
Yeah, where we specified Kotlin compile task, we didn't specify extension of the file. So does it allow does specifying full KT as such?
I am confused. So let's go to the build script. In this, we configured the run Kotlin task, and we just provided this foo_kt as the main class. And you can see that the class here is also called foo_kt when we provided as a class path to run the code. So the compile task doesn't care about foo_kt.
Yeah.
So let's see what happens. If we maybe I'm just misunderstanding this Java exec and how this works, but we can do something different. We can do something like a URL class loader. And what we do is like class path map to yeah, Eugene?
I just wonder, you're just trying to debug the issue and mostly use terminal. I wonder if it's possible to create IntelliJ configuration and like debug plugin execution itself, or
Yeah, sure. We can. I can show this. So if I set a breakpoint here, and I want to debug all of this, I could do something like even run this command and provide -d org Gradle debug, set it to true. I send this command. Starting the daemon will now wait for me in IntelliJ to attach to process. I select the Gradle daemon. I am connected now, and I should now be able to see this breakpoint hitting. So let's, yeah, it's compiling. Yeah, now you see breakpoint hits, and I can just debug the Kotlin plugin and the build. So that was quite simple in my opinion. So we can now also look into what this class path does provide. And we see it actually provides me with foo_kt class, standard library. It also provides me with this build classes. This is not really useful, so it should filter out for only things that are classes. But in any case, yeah, you can debug. Does that answer the question? So then let's see if we can just execute the code on our own without the Gradle util. I'm pretty sure I just misunderstand something here. Let's see if we can get the main class here, and then while main method, and then we can just invoke it. So the autocomplete gave me already quite something nice. So in this case, I don't have arguments. And here main method invoke statically with no arguments should do the job. So I think this one is what we can do. So let's see if this works. And if not, we debug it for 1 more minute. And let's not use debug. And if it didn't work, then we just ran out of time. We already got quite far, in my opinion. Let's stop the daemon. Oh. Yeah, so let's run again. Compiling buildSrc. Compiling the new build script. Yeah, indeed, for whatever reason, foo_kt class not found exception. Yeah, we can add the debugger and see if what is the problem here, and maybe we collectively will be able to spot the problem. And the foo_kt is not within a package, right? So URL class loader, if I look into this, it provides file foo_kt class. I think maybe we can try to filter that it only contains jars or classes and no directories, but I'm not sure if it would make any difference. Oh, not this way. We can do it something like this. Dot filter is file. Let's see if this helps us. If not, then I think see. Yeah, let's go here. Class not found exception of foo-kt. Unfortunately, I don't know what actually is the problem because we have foo-kt here in our class loader. And it should, in my opinion, be able to execute this code. I can try to look up some other code as a reference, or if you give me a second. But I'm maybe new instance can help us. To URI, to URL. Maybe there's also something wrong with the class here and it's not executable for whatever reason. Let's see. No, I don't know what's going on, like why we cannot load this class and why we cannot execute this. UKT. But it looks like at least the classes that we get are correct. The dependencies are here. So I am not sure what's the problem. I'm not sure if we actually are supposed to provide the classes as like CP and then a path to the class, or if we should do it directly. We can do this as one last try to see if it works if we pass the actual just the directory and we do not work with these classes here. But didn't we try this already?
One question: do we need to specify package before the main class?
The package is empty. We do not have a package, but maybe that's just a problem. So we can do something like provide a package and see if this helps us. So the package would be here. Maybe indeed the root package might be a problem. So it's .foo, I guess. So this one would now be the IO semi foo, and then the class is foo-kt. Let's see if this runs, right? Maybe that was the mistake. Let's get this to, let's revert this change here. And I think we can also go and try as the run task. Yeah, let's try run it. Oh, compilation error, unresolved reference bar. Ah, okay. Foo.
This means that dependencies were not provided probably to class pets.
Let's see if maybe we can provide the same package. We need to import it because it's not in the same package anymore. So we need to just import bar. That's what's happening. So let's go foo import bar. Let's see if it compiles again. But again, it says it cannot find foo-kt at this point. I think I call it a day, and maybe in the next session we can figure out what was wrong here, and then go to actually how to use plugins and have some common understanding of what plugins do and how to use them more.
Makes sense.
Okay,
Yep.
then let's call it a day. Any further questions left?
No, only maybe you can share this project with us if you already did not, so
Yeah,
we can look
absolutely.
afterwards. Otherwise, I really like the talk.
Thank you very much. I'm pretty sure, like, once we hang up, it is becoming quite clear to me what is happening here and why it doesn't run the code.
And
It's-
I have a question regarding plugins. You have so currently, like, all plugins apparently are live within a project, so you need to define them to use a plugin. Well, that's okay. But let's say I have a huge project, Gradle project with lots of submodules, and I can't really add, and it's not my project, so I can't add plugin there. Is there a way to run my custom plugin on a, well, kind of remote Gradle project?
Can you try to ask the question once more? Like I meant to pick up.
Yeah, let's say I have an idea of Gradle plugin. Let's say this Gradle plugin just goes through all submodules, Gradle submodules, and prints all names of these modules. But the problem that I have a repository with these Gradle submodules which I can't change. So it is either remotely somewhere in the internet or locally in my directory on my machine. Is there a way to develop such kind of plugin and run this plugin on a remote project?
Yeah, I don't necessarily understand what you mean by remote project and running on a remote project, but I think I got the question, so I can answer it. You can define init scripts in your local home directory.gradle, and inside this init script, you can write code that says something like, for every project that runs, apply this plugin. So even if you open a new, like you clone a new project, you open it, it will apply your plugin by default. And that's, for example, what I do. I have an init script that always sets up a build cache that is like my local server behind me. So if I'm compiling, it sends the output of compilation or whatever tasks I did to the server behind me. And if I go back to this branch 1 year later, I will just retrieve the build from my build server.
Well, it's a bit different, but let's paraphrase. For example, there is whatever, I don't know, like some popular Gradle project like Android. I'm not sure if it's Gradle or not. Let's say it's Gradle with lots of Gradle submodules. How can I run on this project and it's like stored somewhere on GitHub? Is there a way to run my plugin on this project?
But who would execute the code?
Well,
Your machine?
yeah, my machine. I need some results. I need some, let's say, analytics or like walk around the Gradle modules and get something.
I mean, in that case, you would also clone it, right? If your machine executes the code, it should have it available locally. So you would clone it and write and execute some kind of task that comes from your plugin. At that moment, you have it on your machine, the project, and then you can still use this init script to automatically apply your plugin, and you can just clone the project to Gradle W, my special always there task, and it will execute your task that is always available on all projects. And then you can do the investigation and then delete the project once more.
Okay, yeah, that makes sense. Okay, clear. Thanks.
Welcome. Yeah, then I think further questions. If not, then we can call small fix up. Running Kotlin code or the code from our project here is actually quite simple. And one is not supposed to pass each individual class file. One is just supposed to load the classes by pointing to the directory. So changing here the code to not go by a file tree and selecting our class files, but just providing the output directory here. And inside the class loader, not caring about like filtering whether or not something is a file, I can easily just execute the run Kotlin task. So let's do run Kotlin. And we can see that it indeed prints hello from coroutines, hello unit. It just works